invariant method or impulse invariant transformation technique. Okay, this is one of the design of IIR filters from the analog filter. Okay, next before going to bilinear transformation, you know the warping effect. Here the warping effect, actually in this effect you simply remember this equation. So for this equation I am saying the full definition. Okay, let ohm and omega, let ohm and omega, these two are in frequency. Clear, these two are in frequency. Ohm and omega represent the frequency variables in the analog filter and the derived digital filters respectively. This is very important equation, and that should be equal to ohm is equal to 2 by capital T tan omega by 2. So for small values of omega, ohm is should be equal to 2 by T into omega by 2. That means in place of tan omega by 2, you simply write the omega by 2. Already you know tan theta is equal to some value in previous in our intermediate standard. Tan theta, if for small values of tan theta is equal to theta, in place of tan theta you simply substitute theta. So for that like you here 2 by T into omega by 2, and finally omega by T. So ohm is equal to omega by T. In this you write omega value. What is the value of omega? Omega should be is equal to ohm into the cross multiply. Okay, here two phenomena are very important. That phenomena is, for low frequencies the relationship between ohm and omega are linear. Okay, for low frequencies the relationship between ohm and omega are linear. As a result, digital filter have a same amplitude response as the analog filter, like this. Okay, so this is in our first phenomena. Next, go for second one. For high frequencies, the relationship between omega and ohm becomes non-linear. This is very important term. For high frequencies, the relationship between ohm and omega becomes non-linear, and distortion is introduced in the frequency scale of the digital filter to that of the analog filter. So this is known as, finally this effect is known as warping effect. Okay, once you see this diagram, so this diagram also in our Ramesh Babu textbook there, you once you see, clear. So this is linearly increasing. Okay, this effect is shown here only. Okay, finally this effect is known as warping effect. Clear. Next, this is the effect on magnitude response due to warping effect. This diagram is shown simply the effect on magnitude response due to warping effect. Next, to go for pre-warping. So before warping is known as pre-warping. Okay, the warping effect can be eliminated by pre-warping the analog filter. So this can be done by finding the pre-warping analog frequencies using the formula. Already formula is I'm said in startingly, and that should be ohm is equal to 2 by T tan omega by 2. Okay. So next to go for second design of IR filter, and this is the second, already said. Second, what is the second? This is the first, impulse invariant techniques is over. Next, bilinear transformation. These two are in our syllabus only. Okay, next to go for second one. Steps. So in that second also 4 steps are there. That 4 steps are very important for doing a problem. Okay, steps to design digital filter using bilinear transformation technique. In this technique, first step is, from the given specifications find frequency analog, pre-warping analog frequencies using the formula. Already for this formula I am saying 2 techniques, warping and pre-warping. So because of this formula I am saying these 2 techniques. Okay, here the required ohm is equal to 2 by T tan omega by 2. This equation very important. Next, second step for bilinear transformation is, using the analog frequencies find H of S of the analog filter, and this is the second step. And I go for third step, select the sampling rate of the digital filter, and that should be called for a